And welcome to the Daily Space Weather Show. I believe we called for CMEs yesterday. Well, there was at least one major one. And that's the past couple of hours. From GOES 16 SUVI, and as you may have come to expect from the channel, we've got some spectacular imagery for you once again today. June 22nd, 2024. So that is a 24-hour video there. We've put together two of our favorite wavelengths from Solar Dynamics Observatory. That would be 171 plus 304 angstroms ionized iron and helium. Check out the massive Michael Jordan filament there north of the Earth scale. Yeah, we've been naming filaments after our friends, foes, and even ourselves over on Twitter. x.com/SmashoMash. Just follow the hashtag #NameThatFilament. America's soon-to-be favorite pastime. Hoping that one ejects soon, making it more likely that it'll strike Earth. We actually have one happening as we make the video. Also, if you look in the northern hemisphere there, I'll put my pointer just below where that CME is popping off as we make the video. Let me cut back here. The heck? Yeah, you can see that CME there coming off right now, right in there. So right in that area right there. CME coming off. It doesn't look like it will be earthly directed. All right, let's move on here. There we go. So those are 24-hour videos. That's 30 frames per second there. And here is another wavelength. Here we've gotten rid of the 304 angstroms and added 131. And we have a surprisingly low sunspot number. So that was very surprising. And here we've dropped the 131, and now it's just 171 angstroms by itself, the house favorite wavelength. And lots of plasma instability continues once again going into tomorrow. The likelihood of coronal mass ejections is literally 100% because there's one happening this time as we make the video. So there's that. Now, don't forget to press the like button if you enjoy the content. Press the share button to help promote the content on social media. It doesn't seem that YouTube does so why don't you do so on our behalf? If you're new to the channel, press subscribe, and maybe we'll start featuring daily quotes. Today's daily quote is, "I believe the extraordinary should be pursued, but extraordinary claims require extraordinary evidence." A super important quote from Carl Sagan. You know, sometimes people accuse each other of not having an open mind, but I would repeat, extraordinary claims require extraordinary evidence. So before we get into some solar stats, here's some more imagery for you from SDO. That's the colorized magnetogram from the HMI instrument, along with the 171 angstroms from the AIA instrument. Good times, good times. And isn't it great having access to such awesome data? The radio flux has come down actually to 197 now. 197 is the new radio flux number. There it is over the past 365 days from solar.info. Space Weather Enthusiast Dashboard, looking at the possibility of some geomagnetic unrest sometime soon. We have a coronal hole high-speed stream that the density wave is showing up now. It doesn't look like it's going to be super exciting, but we have seen an increase in the solar wind density, which we'll cover here in a moment. As far as incoming space weather, nothing noteworthy besides what's going to be possibly a weak coronal hole high-speed stream. But sometimes the high-speed component of it is very different than the density wave. So you can see this forecast by ESA here. There's ESA's forecast, and yeah, so expecting to see the solar wind density drop off here in the next few hours, and then the solar wind velocity come up along with perhaps a change in the plasma temperature. So we're trying to look at the last 4 hours of Earth's magnetic moment from space here. And unfortunately, it looks like the geospace magnetosphere movies are koofed today. So the ground magnetic perturbations map works, but Earth magnetic moment from space is not loading. So we'll just move on to that. It's geomagnetically calm. And like Noah said, I tend to agree we could see a brief period of geomagnetic unrest, but unlikely to have any significant space weather as a result of that coronal hole high-speed stream. So far, even the density portion of it is fairly mediocre, not particularly exciting. So, but we'll see what happens. Maybe you'll have a stronger magnetic field or something like that with a strong negative BZ vertical component, something like that. Hopefully. KP index currently at 1, KP1, that's geomagnetically calm. And next is solar wind. So ACE not seeing as much of a density spike. Look at the speed of the solar wind, shockingly slow there, only 297 kilometers per second, dropping below 300. That's a really slow solar wind, and not particularly dense there at ACE. At Discover, quite a bit more dense, seeing about 10.5 protons per cubic centimeter, but still below 300 kilometers per second. So no changes to the magnetic field that are noteworthy. And just a little tiny spike there in the plasma temperature, density, and the velocity. So a little bit of material there striking, but besides that, calm conditions, big time calm conditions out at Lagrangian point 1. So here's our GOES magnetometer data, and that's what you'd expect. No major rapid variations happening out there in the outer Van Allen belts. So here's our heliosphere magnetism. North Pole magnetic field continues. So nothing new there. It looks like we'll still have days to go before a South Pole magnetic sector arrives. That's looking like it's 3 or 4 days out there. So in the meantime, we'll have lots of North Pole-oriented magnetism and coronal hole impact. Not really an impact. I mean, it's not really going to do anything. And I'll get back to a point about coronal holes. That's our line of sight field plot. And we have pretty stable conditions in terms of the magnetic fields of the heliospheric sector. Next, coronal holes, which, by the way, not only do they not cause earthquakes, they're not even correlated with major earthquakes. They have zero predictive value with respect to forecasting earthquakes. So there's that. I know people make extraordinary claims. They just lack the extraordinary evidence. So yeah, coronal holes are a thing. And let's take a look at those from the SDO. So there you go. There's some great 211 angstroms imagery for you. And a great job of showing that filament north of the Earth scale then, the MJ filament. Moving on to sunspots, and I would repeat that sunspot number is surprisingly low here. It looked like we had a lot of uncounted sunspot groups, and we have more rising in the southeast. So a second sunspot group there rose in the southeast, or you could say a third group. And it's looking a little bit more magnetically complex, so that's always good. If you're into seeing solar flares, that'll be good news for you. That new series of sunspots. Those won't be counted yet, but now tomorrow we're going to have a bunch of setting groups in the west. So not exactly sure, but it looks like, based on what I see, we're going to actually see a decline in sunspot number going into tomorrow. So that's the scenario. That's the Royal Observatory of Belgium sunspot counting. Here is our flare probability monitor and scoreboard. And what do you got? What do you got? What you got is a high likelihood of major flares on that western limb. So 3716, the northernmost of those three large groups on the western limb, was the most active sunspot of the past 24 hours. But the most complex magnetic fields remain in the southern group. So 3712 is the most likely to produce a large flare, followed by 3713. So very high likelihood of large solar flares, including of the X-class variety, as you can see from the flare probability scoreboard there. And let's take a look at sunspots from the SDO's HMI instrument. So that's our magnetogram. And if you look at that relatively new sunspot there in the southeast, there is a second group behind it, which is looking a little bit more magnetically interesting. We'll show close-ups of it toward the end of the video. That's 24 hours at 30 frames per second. And there is the continuum. We're going to zoom way in on the most active sunspot, which is 3716, the producer of the most recent M-class flare. And there is its magnetogram. So it's been largely stable over the past 24 hours. Nothing too exciting going on there. And before we get to energetic particles and flares, we are on energetic particles and flares. So the likelihood of a proton event remains very high, especially with the likelihood of large solar flares at that western limb. So don't be surprised to see an SEP and polar radio blackouts and so on. Largest flare of the past 24 was from sunspot 3716 around 8:55 Universal Time this morning. It was an M2.85 class solar flare. And here are flares from SDO. We've put together 94 plus 131 angstroms. The two higher temporal resolution wavelengths from the AIA instrument. Higher temporal resolution. More frames per minute are taken by that instrument. The 94 and 131 angstroms wavelengths. Specifically designed to study solar flare activity. There's that low-level M-class flare just before 9 o'clock Universal Time this morning. Next, the solar system forecast. Before we get to coronal mass ejections, there is where things are today. That's where things will be on the 29th, 1 week from now, as the moon becomes a crescent waning. And this is what's going on over our head. If you're viewing the early evening sky and you've got a very low horizon, you might be able to see Venus and Mercury there setting just behind the sun. If you're someplace like the west coast of somewhere, for example, you may be able to see Mercury and Venus just chasing the sun over the horizon. Astronomy photo of the day is a dark absorption feature-laden nebula, complete with Herbig-Haro objects, which are, we'll say, very dusty and very active stars. So stars that are really tightly encased in very dense dust clouds, Herbig-Haro objects. They tend to have polar jets, or things that look like polar jets, which are sort of the area of least resistance in that there's less material there as a result of coalescing on the equatorial plane of the star and so forth. Anyway, apod.nasa.gov, that is Nebula 1251. LDN, Lind Dark Nebula 1251. apod.nasa.gov. Now, unfortunately, one of our coronagraphs is down, and we're just going to skip straight to the custom coronagraphs, because really it's just a spectacular light show there. That big CME that you see coming out of the east, that's somewhat behind the solar limb. That's not earthly directed. So, but like I said, we've got a 100% chance of additional coronal mass ejections for the next 24 hours because there's one happening as we make the video. So that's a thing. And that's coming right out of the north, slightly to the west of center. You'll be able to see it right at the end of the video. You'll see a filament start to lift off there, that coronal mass ejection unfolding as we record this very content. So we'll zoom in a little bit closer here, and then we'll get to filaments, and then we'll cut back to this. So filaments. There is a nice set of filaments, if I've ever seen one. So let's see, we've got 1, 2, 3, 4, 5, 6, 7, 8. Got about 8 or 9 filaments right now. You can see this one lifting off right at the end there from the Big Bear, California. Hydrogen Alpha Solar Observatory. There's the grayscale imagery. And there are some new active regions and associated prominences rising with them, thanks to their magnetic fields. And before we get the bonus features, well, we'll close out with filaments. We'll do bonus features real quick, and then we'll cut to our fantastic filamentary imagery. So here's 131 angstroms from GOES 16. We did have a little bit of flaring happening there over around the east. It has been minor. Here come bonus features. No satellite charging hazards. Electron flux here, similar to yesterday's levels, a little bit higher. The GOES 18 there getting a little bit above the alert threshold. The 10 to the third particles per cubic per square centimeter, negative square centimeter. Basically, it's a count of free electrons at the F layer. There's a forecast model from NOAA expecting a decline, and that would be something that would be normal for a coronal hole high-speed stream impact, so tend to agree with that. Next, we'll show the layer where it's measured, which is the F layer, and the bridge between Earth and space starts at the D layer of the ionosphere, where the atmosphere switches from being mostly neutral particles to being mostly charged particles. That's the bridge between Earth and space. The F layer is quite a bit higher than that at about 300 kilometers of altitude. Here it is in its vibrational frequency. And if that's Greek to you, don't worry, we'll show the anomalygram, where even somebody who's never seen the map before, upon looking at the anomalygram, should provide some insight into what's going on. So there's anomaly in megahertz from a 30-day median, and a little bit of action happening up there. And I would note the South Atlantic anomaly, once again, remains around 45 degrees west longitude. Look at that 45-degree line as it reaches the South American coast. The South Atlantic anomaly is way over there now. Facts. Is that a reason to get in the bunker? I don't think so, but if you'd like to get in the bunker, feel free. We encourage you to bunker up if you think it's going to improve things somehow. Certainly, bunker up, folks. Bunker up, yes. If you feel the urge to bunker, then bunker up. Can't imagine why anybody would want to bunker up. Everything's been working so well for the... yes. By the way, there are links to the merch below the video. Some quite original designs indeed. So that's our Global Ionosphere Nowcast that depicts total electron content and maximum usable radio frequency. We'll close out with the latest. Oh, and I wanted to just say that I misidentified this sunspot yesterday. So this group over here with these two very similar sunspots right in here, that's actually an alpha class sunspot. They're all South Pole orientation there, so that's pretty unremarkable. However, the group that's rising behind it is better. So that's a little more exciting of a group there. It's a little bit more chaotic looking, and that's what you want to see if you want to see solar flares, and we do on the channel. So let's take a quick tour of these Western groups. I'm just going to scroll down for each of them. Yeah, 3712 is quite volatile looking. That is the UV map of planet Earth. I apologize. We've suspended the meteorology segments because it's a little bit too pedestrian. So there you go. There's what's going on. And it's about time to show our filament images. I don't want to leave those out. All right, so we'll close out with filaments. That will be an ongoing story. Again, the likelihood of coronal mass ejections is literally 100% as one is happening while we make the video. So we'll zoom in here a little bit closer. That CME is popping off right up here, right at the end of the video, right in there. And last but not least, the Michael Jordan filament. One of the largest filaments seen on the Earth side of the solar disk in approximately 6 years. It's one of maybe 3 that were around that size, density, etc. And we'll close out today's daily space weather video with 304 plus 193 angstroms. Also great at showing filaments there. No difference imagery required. So that's where we'll close things out. Thanks for tuning in to the Daily Space Weather Show. Accept no imposters. We'll see you next time. And in the meantime, may that solar wind be at your back.